Dwarf planets, a fascinating and intriguing class of celestial objects, are the focus of our exploration today. These cosmic bodies, smaller than planets yet larger than asteroids, occupy a unique place in our solar system. The term dwarf planet was first introduced by planetary scientist Alan Stern and later officially adopted by the International Astronomical Union in 2006. This classification was a significant development in the field of planetary science as it recognized a new category of celestial objects that had not cleared their orbital path, unlike planets. This distinct class includes 5 officially recognized members: Ceres, Pluto, Haumea, Makemake, and Eris, each with their unique quirks and characteristics. So, buckle up, space enthusiasts. Join us on a journey through the cosmos as we delve into the unique characteristics and locations of the officially recognized dwarf planets in our solar system. In our solar system, 5 celestial bodies are officially classified as dwarf planets: Ceres, Pluto, Haumea, Makemake, and Eris, and 5 are waiting to be classified as dwarf planets, which are Gonggong, Orcus, Quoor, Sedna, and Salacia. As of now, total 10 dwarf planets are there. Let's start off with Ceres, the smallest of the lot, but not to be underestimated. It's the first dwarf planet ever discovered, residing comfortably in the asteroid belt. Despite its smaller size, Ceres holds its own, boasting a fascinating past and a future ripe for exploration. Next in line is Pluto, the largest of the dwarf planets and perhaps the most well-known. Once considered the 9th planet of our solar system, Pluto's status was redefined in 2006. However, its size and intriguing characteristics, such as its heart-shaped glacier, continue to captivate our curiosity. Moving on, we have Haumea, a celestial body known for its peculiar elongated shape. This unique dwarf planet, located beyond Neptune's orbit, also has 2 moons of its own, proving that size isn't everything when it comes to making a mark in the cosmos. Following Haumea, we have Makemake. Named after the creation deity of the Rapa Nui people of Easter Island, Makemake is another interesting resident of the Kuiper Belt, the region beyond Neptune's orbit. Its reddish hue and lack of an atmosphere make it a standout in the cosmic neighborhood. Last, but certainly not least, we have Eris. Slightly smaller than Pluto, Eris is the most distant dwarf planet from the Sun. It's also one of the coldest, with temperatures that could freeze nitrogen. Eris is a testament to the diverse and extreme environments that exist within our own solar system. Each of these dwarf planets presents a unique world, ripe for discovery and exploration. The first dwarf planet discovered, and the smallest of the 5, is Ceres. This celestial body, nestled within the asteroid belt, is a unique entity, distinct from its other dwarf planet siblings. Primarily, its location sets it apart. While the majority of recognized dwarf planets reside in the outer regions of our solar system, Ceres makes its home between the orbits of Mars and Jupiter, right in the bustling asteroid belt. Now, you might be wondering, what's so special about this asteroid belt resident? Well, in 2015, Ceres had a rather notable visitor. NASA's Dawn spacecraft, on a pioneering mission, sailed through the cosmos to pay Ceres a visit. This marked a significant milestone in our understanding of dwarf planets, and particularly of Ceres. The Dawn spacecraft, equipped with a suite of sophisticated instruments, was able to capture detailed images and data of this dwarf planet. It revealed a world of rock and ice, with a rugged landscape scarred by craters and interspersed with mysterious bright spots. The data collected by Dawn gave scientists a wealth of new information to analyze, and led to numerous discoveries about Ceres' composition, history, and potential for life. So why does Ceres matter? The answer lies in its age. Ceres is a relic from the early solar system, a snapshot of the cosmic environment that existed around 4.5 billion years ago. By studying Ceres, scientists can gain insights into the processes that led to the formation of planets and other celestial bodies. This makes Ceres not just a dwarf planet, but a time capsule of cosmic history. Ceres, an intriguing world of rock and ice, offers a glimpse into the early solar system. Pluto, once known as the 9th planet of our solar system, is the largest of the dwarf planets. For over 70 years, from its discovery in 1930 by Clyde Tombaugh until 2006, we knew Pluto as the 9th and most distant planet from the Sun in our solar system. However, the year 2006 marked a turning point for Pluto's identity. The International Astronomical Union, the governing body responsible for naming and classifying celestial bodies, reclassified Pluto as a dwarf planet. This decision was based on their updated definition of a planet, which requires the object to have cleared its orbit of other debris. Despite its impressive size and unique characteristics, Pluto, along with many other celestial bodies in our solar system, did not meet this criterion. The reclassification of Pluto was a significant event in the world of astronomy, leading to the introduction of a new term, Plutoids. This term is used to describe a subgroup of trans-Neptunian objects, essentially dwarf planets that orbit beyond Neptune. As the prototype of this group, Pluto holds a unique position within our solar system. Although Pluto may no longer hold the title of the 9th planet, it continues to captivate astronomers and space enthusiasts alike. Its unique characteristics, such as its icy surface, its 5 known moons, and its elliptical orbit, make it a fascinating object of study. The New Horizons mission by NASA, which flew by Pluto in 2015, provided us with the most detailed images of Pluto's surface to date, further deepening our understanding of this complex world. Despite its demotion, Pluto remains a captivating and complex world, far from forgotten. It continues to play a significant role in our understanding of the outer regions of our solar system and the myriad celestial bodies that reside there. Beyond Neptune's orbit, we find the remaining dwarf planets, Haumea, Makemake, and Eris. Now let's take a journey to the outermost regions of our solar system where these intriguing celestial bodies reside. Each of these dwarf planets, despite sharing the same category, boasts unique characteristics and mysteries that continue to fascinate astronomers and space enthusiasts alike. First up, we have Haumea, a fascinating dwarf planet with an unusual elongated shape due to its rapid spin. This distinctive feature sets Haumea apart from its spherical counterparts. Not only is Haumea one of the fastest rotating large objects in our solar system, it also has 2 moons of its own. This celestial body is shrouded in a layer of pure crystalline water ice, giving it a shiny appearance that stands out in the darkness of space. Next, we journey to Makemake, named after the creation deity of the Rapa Nui people of Easter Island. Makemake is the second brightest object in the Kuiper Belt, only surpassed by Pluto. It is known for its reddish-brown color, which is believed to be caused by the presence of methane ice on its surface. Despite extensive observations, no moons have been discovered orbiting Makemake, making it an anomaly among the large Kuiper Belt objects. Lastly, we venture to the most distant of the recognized dwarf planets, Eris. Discovered in 2005, Eris was initially thought to be larger than Pluto, leading to a redefinition of what constitutes a planet and ultimately to Pluto's own reclassification. Eris is accompanied by a single moon, Dysnomia, and its highly elliptical orbit takes it nearly twice as far from the Sun as Neptune. All 3 of these dwarf planets, Haumea, Makemake, and Eris, are known as trans-Neptunian objects, meaning they orbit the Sun at a greater average distance than Neptune. These bodies inhabit the icy realms of the Kuiper Belt and the scattered disk, regions beyond Neptune that are home to countless other minor planets and icy remnants from the formation of the solar system. These distant worlds, shrouded in mystery, beckon us to unravel their secrets. 2 regions of our solar system, the Kuiper Belt and the scattered disk, are home to many dwarf planets. The Kuiper Belt, a region of space beyond Neptune's orbit, is akin to an outer asteroid belt. It's a vast, cold and dark region teeming with small bodies made primarily of ice. These icy objects, remnants from the early solar system, include comets, asteroids, and many dwarf planets such as Pluto, Haumea, and Makemake. The Kuiper Belt is crucial in the study of dwarf planets as it hosts a significant number of these celestial bodies, offering a glimpse into the raw materials that helped shape our solar system. On the other hand, we have the scattered disk, an even more distant region of the solar system. It's like the Wild West of our cosmic neighborhood, with objects in highly elliptical, unpredictable orbits. This region is believed to house numerous dwarf planets, including the infamous Eris, which is larger than Pluto and was pivotal in the reclassification of what constitutes a planet. The scattered disk is also the origin of some short-period comets, which swing by the Sun on a regular basis. As these icy bodies travel inwards, they provide a unique opportunity to study the primordial substances from which our solar system was formed. Both the Kuiper Belt and the scattered disk are critical in understanding the formation and evolution of our solar system. They are like cosmic archaeological sites, preserving the early history of our solar system and the building blocks of planets. The exploration of these regions and their resident dwarf planets helps us understand the dynamic nature of our solar system and the fascinating variety of bodies that inhabit it. From the icy, rocky surfaces of these dwarf planets to their unique orbits and interactions with the Sun, there's a wealth of information awaiting discovery. These distant regions serve as celestial treasure troves, teeming with dwarf planets and other icy bodies. While similar in many ways, dwarf planets and planets are distinct classifications of celestial bodies. The cosmos is a vast expanse teeming with celestial objects, each with its own unique characteristics. Among these, we find planets and dwarf planets, two classifications that, while seemingly similar, have key differences. At a glance, one could mistake a dwarf planet for a planet. They are both celestial bodies orbiting the Sun, and they're both spherical, giving them a planet-like appearance. However, the devil, as they say, is in the details. The International Astronomical Union, the authority in charge of classifying celestial objects, has laid down 3 criteria for a celestial body to be classified as a planet. These are: it must orbit the Sun, it must be spherical, and it must have cleared its orbit. It's this third criterion where dwarf planets fall short. Unlike planets, dwarf planets haven't cleared other objects in their orbit. Essentially, this means that while planets have gravitational dominance in their orbits, dwarf planets share their space with other celestial bodies. The exploration of dwarf planets is a field ripe with potential for new discoveries. As we venture further into the outer reaches of our solar system, dwarf planets become increasingly significant to our understanding of the cosmos. These celestial bodies hold clues about the early solar system's formation and evolution. They serve as frozen time capsules, preserving a history billions of years old. The future of dwarf planet exploration is exciting and promises a wealth of new knowledge. Consider the New Horizons mission to Pluto, for instance. It gave us our first up-close look at a dwarf planet, revealing a surprisingly active world with mountains, plains, and even a heart-shaped glacier. The mission transformed our understanding of these distant bodies, proving that they are far from dead, frozen worlds. Planned and proposed missions to dwarf planets aim to build on this momentum. Ongoing projects like NASA's Lucy mission, set to explore Jupiter's Trojan asteroids and possibly even dwarf planets in the Kuiper Belt, are on the horizon. These missions will enable us to study the composition, geology, and atmospheres of these bodies, offering insights into the broader context of our solar system's history. The potential discovery of more dwarf planets, particularly in the outer solar system, is another exciting prospect. The search for the elusive planet 9, for example, might lead us to identify new dwarf planets, further expanding our understanding of these fascinating celestial objects. The quest to explore dwarf planets is not just about scientific discovery, it's also about pushing the boundaries of human endeavor and technological innovation. Each mission requires the development of new technologies and strategies to overcome the unique challenges of space exploration, from the vast distances involved to the harsh conditions of the outer solar system. In conclusion, the future of dwarf planet exploration is a thrilling frontier. It's a journey of discovery that will deepen our understanding of the cosmos and our place within it. As we continue to explore these enigmatic worlds, who knows what mysteries we will uncover. Our journey through the realm of dwarf planets has taken us from the asteroid belt to the far reaches of our solar system. We've explored the 5 officially recognized celestial mavericks, each with its unique traits and locations. Ceres, the smallest yet closest, nestled in the asteroid belt. Pluto, once the 9th planet, now reclassified, yet still priding in being the largest dwarf planet. The outer trio, Haumea, Makemake, and Eris, each with distinct characteristics and stories to tell. We've journeyed through the Kuiper Belt and the scattered disk, the regions where most of these celestial bodies reside. Our exploration has highlighted the key differences between planets and dwarf planets, with the latter's inability to clear their orbits as a defining factor. As we look to the future, we anticipate uncovering more secrets and uncharted territories in this fascinating world of dwarf planets. As we continue our cosmic voyage, we look forward to unveiling more of the dwarf planet's mysteries. Please subscribe for more videos.